Previous couple of videos, we've looked at how to write electronic configurations for atoms of different elements. And we also looked at a couple of strange or funny exceptions to the general rules that we've learned. In this video, we're going to make the idea a little bit more complicated, so we're always building another layer on. And we're going to begin by looking at the example of the element lithium. Okay. Now, lithium has an atomic number of 3 if you look at your periodic table. And what this means is that lithium has 1, 2, 3 protons, and each one has a positive charge. So we'll say there are 3 positive charges. And it also has 3 electrons. So it's got 1, 2, 3 electrons, and each one has a negative charge. And that's why overall our atom is neutrally charged, because there are equal numbers of protons and electrons. Now, the number of protons in an atom can't change. We know that already. If the number of protons changes, it's not lithium anymore. But what can change is we know where the electrons are. They're arranged outside the atom. And sometimes electrons can lose sometimes atoms can lose electrons or can gain extra ones. So let's look at what happens to lithium if it loses an electron like this. Okay. If lithium loses an electron, then we would show that this is now a lithium that has 3 positive charges and only 2 negative charges. So now the charges aren't balanced anymore. And we would describe this as a lithium atom with a 1 plus charge. Okay, it's got 1 extra positive charge net. Okay, so if we're looking at the overall amount, it's got an extra positive charge. That doesn't mean it gained a proton. It's still lithium. What it means is it lost one of its electrons. It lost one of its minus charges. This here is what we call a charged atom. This is an atom with a charge. In chemistry, we have a word for these things. We call them ions. Okay, so what is an ion? An ion is an atom with a charge. Now, we'll not go too much into ions right now because we're going to do them again in the future. I just needed you to be aware of what an ion was before we go into electronic configurations of ions. Okay, so the first step to do then is figure out, well, how many electrons does my ion have? Now, I would suggest that if you're really not sure, that you do what I've done here. You write out the pluses and minuses like I've done. Now, the thing about this is that the most common mistake I see people make is that when they see this 1 plus, they think that means plus 1 electron. It's gained 1 electron. That's not what it means, of course. We know it actually means the opposite. It's lost 1 electron. So if you're ever not sure when you see the sign, say you see F minus 1, or F1 minus, and you're not sure what that means, well, go back to this example, write this example out because this is easy. There's only 3 protons and 3 electrons. It's really quick to write and see what that means. Okay, so if I lose an electron, what does that make it? Well, you can clearly see here there are 3 plus charges and there are only 2 electrons, and that's what makes it plus 1. So if we looked at fluorine, this would be the case then. Fluorine has an atomic number of 9. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And normally fluorine also has 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. And that's normally balanced. But this is a charged atom, which means it's 1 minus. So what does that mean? Well, the only way it can become a 1 minus overall is to get another electron. So altogether here, you can see that there is now 9 protons and 10 electrons. So again, if you're ever not sure, I advise you to write out a simple example like this one and work from there. And that's how you can always figure it out. Okay, so once you're able to do that and figure out how many electrons you have, then we can write the electronic configuration. So let's do lithium here. Li, lithium. Okay, so it's Li and it's plus 1. So how would we write the electronic configuration for this? Well, it has, as we worked out up here, 2 electrons. So how would we do this? Well, the first 2 electrons, we know where they always go. They go into 1s sublevel, so 1s2. And that's it. There's only 2 electrons. So what we want to do then, though, to show that it's not just the same as an atom that's got 1s2 configuration, we want to put square brackets around it and show that this is plus 1 charge on top of this. So it's 1s2 with a plus 1 charge. So that's how we would do an electronic configuration for an ion. All right, so what I want you to do now is I want you to pause the video and try do the electronic configuration for this here, fluorine 1 minus. So pause the video and do that now. Okay, so hopefully you've been able to do that because we've already showed you that there's 10 electrons here. I've given you a bit of help with that. I have kind of allowed you to take one step on top of the help you're given, and then the next step is to do it all by yourself. Okay, so what are we talking about here? We're talking about F1 minus. And the configuration is, well, we've got to get 10 electrons. So 1s2, 2s2, that's 4 electrons, 3p6. That's 10 electrons, that's exactly right. But we don't want to leave it like that. We want to show that this is an ion. So we're going to go square brackets and a -1 like that. So if you got that right, well done, take it. If not, make your corrections now. Okay, and what I want you guys to do now is I want you guys, I better, sorry, I need to get rid of this. I don't want you to see the answers, obviously. I should have had this done beforehand, apologies. Okay, so what we're going to do is we are going to go ahead and we're going to do these 5 here. Okay, so the first thing I want you to do is I want to work out how many electrons there are. So I'll do the first one for you. Magnesium 2 plus has 10 electrons. So I'll help you with that one, and then you do the configurations, and then you go to the next one and work out the number of electrons and do the configuration and so on. So pause the video, do that now. All right, so Magnesium 2 plus has a configuration like this: 1s2, 2s2, 2p6, square brackets. This is an ion with a 2 plus charge. All right, next one, p3 minus. You should have got that it has 18 electrons, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, square brackets, 3 minus. Okay, next one. Oh, this one's quite a long one. 1s2. Oh, sorry, how many electrons it has first? It has 36 electrons. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p6. All right, so quite a long one there. And obviously that's a 1 minus charge at the end. Sodium has 10 electrons, and it's 1s2, 2s2, 2p6 with a +1 plus charge, and then O2 minus also has 10 electrons. 1s2, 2s2, 2p6, 3. Oh no, that's it. Sorry, that's it. Need to stop there. Square brackets, and that's a 2 minus. Now look, you can see that there are actually 3 things here that all have the same amount of electrons, and that's why it's really important that we show at the end the chart. Not that one, sorry, that one, that one, and that one, because otherwise these 3 are all the same. Okay, so it's really important that we show how they're different. They're different because they've got different charges on the ion. All right, so that's the electronic configuration of ions. Again, hopefully that wasn't too much of a step up from what we've already done. It should be pretty straightforward. And you can now see that actually different elements or different ions can have the same electronic configuration, because ions can end up having the same amount of electrons as each other. So it's actually how many electrons something has that determines what the electronic configuration is going to be. Okay, all right, that's it. See you in the next one.